dot product. Prove that the diagonals of a rhombus are perpendicular. This is a rhombus, okay? Now, all the sides, all the four sides, they are equal, okay? So, this vector A and B, they have the same magnitude. Now, you see, we want to prove that this diagonal AB is perpendicular to CD. Now, we can see here that vector A plus vector B is equal vector BA. It's better to put BA or AB. Okay, let's put BA. BA. Now here, okay, you have A plus CD, you see? A plus CD is equal B. Now, A plus vector CD is equal B. CD is equal B minus A. Now, the dot product of BA dot CD is equal. This is A plus B dot B minus A. This is equal. Now, A dot B minus A dot A squared. Now, B dot B plus B squared, and B dot minus A is minus B dot A. Okay? Now I can cancel here, and this is since A is a magnitude, this A is magnitude of vector A, which is equal the magnitude of vector B. Okay? Look. Because the rhombus, all the sides, they are equal. So BA dot CD is equal. Now B squared minus I squared, B squared minus I squared, which from here is equal 0. So BA dot CD is equal 0. This implies that BA is perpendicular to CD. Okay? It's a very simple. We just used the concept, the definition, the geometric definition of dot product. Prove that cosine of the difference alpha minus beta is equal cos alpha cos beta plus sine alpha sine beta. Okay, now this is my axis, x1 and x2. Suppose that's a vector v, that's a vector u. Vector u. This is the angle alpha, this is angle beta. This is alpha and beta. Okay, this angle here, okay, this will be alpha minus beta. So, let's get the dot product u dot v. Okay. Now is the magnitude of vector u times the magnitude of vector v, the cosine of the angle between v and u, or u and v. So this is alpha minus beta. Now, the left hand side, okay, we can write u is equal, in this case, u plus U2, E2, okay? On the x1, x2 plane. Likewise, V is equal V1, E1 plus V2, E2. You can see the projection here, okay? This is V1, okay? E1 is the unit vector of the x1 axis, and E2 is the unit vector on the x2 direction. See, this is a standard basis. Don't forget that, okay? We are using a standard basis. What is a standard basis? Okay, E1 dot E1 is equal E2 dot 2 is equal 1. Then E1 dot E2 is equal E2 dot E1, which is 0. Okay? This is what we call a standard basis. Now, what is V1? Let's first U1. Okay? U1 is equal the magnitude of the vector U times cosine. You see the U here is a cosine of alpha. U2 is equal U sine of alpha. So this is V1, this is V2. Here this is U1, and here is U2. Okay? Now, likewise, V1 is equal V times cosine, you see, because V, okay, the angle beta, the cosine of beta is equal V1, V cosine of beta. Now, V2 is equal V sine of beta. So, let's substitute, okay? U dot V using these components. So I can write, let's separate here, U, I put, in this case, U will be, U is U1, E1 plus U2, E2. Dot, now vector V, okay, vector V here will be V1, E1 plus V2, E2. This is equal, now here U1, V1, okay, U1, V1, because E1 dot E1 will be 1. Now, E1 dot E2 will be 0, plus U2 V2. Now, I'll substitute these components. So this will be equal. Now, U cosine alpha, U cosine alpha, that's U1, okay? Now, V1 is V cosine beta, okay? Now, plus U2 is U sine alpha, plus times V2. V2 is V sine beta, okay? This is equal, now I have UV that multiplies cosine alpha, cosine beta, plus sine alpha, sine beta. Okay, this is equal to the right hand side. Okay, this here is u, you see, u dot v. U dot v in the left hand side, which is this. Now I will compare with the right hand side. So this is equal uv cosine of alpha minus beta. Now I cancel uv. That's exactly what I want. Cosine of alpha minus beta is equal cosine alpha cosine beta plus sine alpha sine beta. So in the x1 x2 plane, find the matrix that rotates a vector by an angle theta. Let's draw my x1 x2. This is my vector v. This rotates by an angle theta. Okay, I'll call v prime. Okay, v prime is a vector v that rotates and reach this point over here. Now, I'll break down the components of v. Okay, this will be v1 and this v2. This angle here is beta and this angle is alpha. Now, v1 is v cosine of beta. v1 is v cosine of beta. Now, v2, okay, is v times sine of beta. Okay, this is beta over here. Okay, look, this angle here is equal to this angle here. So v2 is v sine of beta. Now this is v prime. Okay, now I'll do like this. See, look, I have here, I project here, this is v prime 1, okay? And the projection here, this is v prime 2. So v prime 1 is v prime, the magnitude, times cosine of alpha. You see, alpha, this angle here. Okay, this is alpha. Then v prime 1 is v prime, okay, cosine of alpha, and v prime 2 is equal v prime sine of alpha. But you see that the magnitude of v prime is equal magnitude of v. Okay, let's call, for instance, let's call A. Okay, A is a magnitude because this vector only rotates. Okay, now from here, just write this A, this is A, this is A, this is A. Okay, now what is alpha? You see, what is alpha? Alpha is beta plus theta. So alpha is beta plus theta. So I'll substitute alpha right over here. So v prime 1 is equal A, okay, because v prime, you see here, v prime, the magnitude of v prime is A cosine of alpha. This is beta plus theta. Plus, in this case, okay, let's put here, now, v prime 2 is equal, v prime is 2 is a sine of beta plus theta. Okay? Now, I will expand this. V prime 1 is equal a cosine of beta plus theta. This is cosine, will be cosine of beta, cosine of theta, minus sine of beta, sine of theta. Okay, this is A. Now, V prime 2, V prime is A. Now, sine of beta plus theta, okay? This is sine of beta, cosine of theta, plus sine of theta, cosine of beta. Okay, that is sine of the sum of two angles. Now it's quite easy. You see, look. What is a cosine beta? Okay, a cosine beta. You see, this is a. Okay, this is a. A cosine beta is V1. So here, I will raise here and write down. Okay. Now, this V prime 1 is equal, you see, a cosine beta is V1, okay? Is V1 cosine of theta minus a sine beta is V2, is V2 sine of theta. Now, V prime, let's put the V here. Now, V prime 2 is equal, look, a sine beta is just V2. So, this will be V2 cosine theta plus a times cosine beta is V1 plus V1 sine of theta. Now, you are ready to find the matrix which rotates this vector V and vector V prime. Okay? You just write like this. This I put V prime 1, V prime 2. Okay? Now comes the matrix. I will raise that. I will raise right here. So, this matrix operates, okay, on V1 and V2. You see? Now, V1, V2. So this is cosine of theta. This is minus sine of theta. Okay, let's expand, let's raise here, just to not put all together. Let's put the matrix here, and the matrix here. This is V1 and V2. Now, cosine of theta. This is minus sine of theta. You see, this first row times this column is V1 cosine theta minus V2 sine theta. Here is V2. This is V1. So it has to be sine of theta and then cosine of theta. Okay? Just check. Okay? The second row in this column, V1 sine theta plus V2 cosine theta is here. Okay? So that's the matrix. This matrix, okay, let's call matrix M. This M rotates, okay? You see the components of vector V, these are components of the vector V prime. This is the matrix. Now, let's do let's do the opposite. You see, the components of V prime, there's a matrix which rotate the vector V1, V2 of the component on this component. Now here I'll do just the opposite. Okay, you see, V1 is V cosine beta, V2 is V sine beta, okay, or A, okay, the same. Now you see who is beta here, okay, this angle here is alpha minus theta, that is beta. So let's substitute here. And also here, V1 prime is A or V cosine alpha, V prime 2 is V sine alpha. So let's substitute over here. So V1 is equal, let's put A here, okay, because this is equal to A, okay, A cosine alpha minus theta, okay? Cosine of beta is alpha minus theta, and V2 is equal A, okay, sine of alpha minus theta. Hence, V1 is equal A, now cosine alpha cosine theta, this is minus, so this is plus A sine alpha sine theta. Now this one, V2 is equal A sine alpha cosine theta, this is minus, so this is minus A cosine alpha sine theta. Now you see, A cosine alpha, A, this is same as A, okay? A cosine alpha is V1 prime, so here is V1 prime. A sine alpha is V2 prime, V2 prime. Likewise, this is V2 prime, and this is V1 prime. Now we are ready to write the matrix. Okay, here is V1, V2 is equal, here's the matrix, the operator. Okay, let's increase it here a little bit. So this is V1 prime and V2 prime. Now, you see the first row, this will be here. Now, we have here V1 prime cosine theta, so cosine theta. Now, plus V2 prime sine theta, so this is sine theta. Now, the second row, this is V2 prime cosine, okay? Then I put here cosine. And this is minus, this is V1 prime minus sine of theta. Now, let's substitute, okay, this column here. Okay, you substitute this here is V1 prime and V2 prime, okay? This product here, you just substitute, and then let's see, first row, first column, so cosine square of theta plus sine square of theta, okay? This row, first row and first column. Now, second row and first column, second row and first column. So this is minus sine theta cosine theta plus sine theta cosine of theta. Okay, let's erase here and make this matrix bigger here. I'll put here cosine plus, this is cosine, let's put here, cosine square of theta plus sine square of theta. Now, here, okay, it will be first row and second column. So this will be minus sine of theta cosine of theta plus now this times this plus sine theta cosine of theta. Okay, now here second row second column, second row second column, minus times minus is plus sine square of theta plus cosine square of theta. This is V1 and V2. Now, you see here is 1, here is 0, this one is 0, and this is 1. So V1, V2 is equal the identity matrix. This is 1, 0, 0, 1, V1 and V2. Now, this is a very, very important and relevant result because you see, when you are dealing with a standard basis, so the standard basis is standard basis. Okay, what is the standard basis? It's the orthonormal basis. You see, this matrix here is the inverse of this, and you see clearly that the first row of this matrix is my first column. So these matrices, they are the transpose. This makes a transpose of this matrix, and vice versa. Okay. Now, the product is the identity. Now, the very, very relevant result when you operate with the standard basis, orthonormal basis, the inverse is equal to the transpose. Okay? That's a very relevant result. See, you see here. Okay? Just, I would like to emphasize, if you work only with the standard basis, let's find a matrix in which it correlates the standard basis to another standard basis by rotation. So this is my x1 x, this is my x to x. So consider this is x1 prime, this is an angle theta, and this rotation here. Okay, this is x2 prime. Okay, now the unit vectors. This is from the standard basis. This is E1. Here is E2. Now, here I'll write down. This is here. I'll put E prime 1 from x prime 1, and here E prime 2. Okay, that's let's say this basis E1 prime and E2 prime. Let's make here this 1 prime. Okay, that's better here. Okay, now E1 and E2, let's fix on this base E1, E2. So I can write E1 prime as a linear combination of E1 and E2. So it's A E1 plus B E2. Now E2 prime as a linear combination of E1 and E2. A and B, C and D are the unknowns. Now, let's do this. Since E1 dot E2 is equal 0, and since E1 dot E1 is equal E2 dot E2 is equal 1, and E1 dot E2 is equal 0, that's the standard basis, okay? Let's multiply both sides here. E prime 1 dot, and the other side is A1 plus B E2 dot. Let's multiply both sides, okay? Let's make the dot product of E1 prime. Let's put here E1, okay? Now here's E1. Now E1 dot E1 is 1. E1 dot E2 will be 0, so this will be equal to A, okay? Because E1 dot E1 is A. Now, what means this? Okay, it means that the dot product will be the size or the magnitude of E1 times the magnitude of this is E1 prime times the cosine of the angle between E1 prime and E2 and E1 and the E1. Okay, look, this is E1 prime and this is E1, so it will be cosine of theta. Okay, this is equal A. Now, this is 1, this is 1. So A is equal cosine of theta. Now to get B, to obtain B, I multiply by E2. Okay, then I'll put right here. Okay, this is B. This, look, this E1 prime. Okay, this E1 prime. I multiply by sides by E2. So here will be E2. Now, E2 dot E1 will be 0. So E2 dot E2 will be 1. So this is equal B. Okay, it's quite easy. So this dot product here will be E prime 1. Okay, now E2 time cosine of the angle between E1 prime and E2. Now, this is 1 prime, okay, E1 prime, and here is E2. So this angle here is 90 minus theta, okay, this is theta. So cosine of 90 minus theta is sine of theta, okay. Then I'll put here cosine of 9 minus theta. So this is equal B, okay, and this is equal sine of theta is equal B, okay. Now I have B and A, okay. A is cosine of theta and B is sine of theta. Let's do the same to try to find out C and D. So here, this E2 prime, okay, dot E1, okay. What is E2 prime? Is C E1 plus D E2 dot E1. So E1 dot E1 will be 1. E1 dot E2 will be 0. So this is equal C. Okay. Now, here is a module, okay, the magnitude of u2 prime, the magnitude of u1 times the cosine of the angle, okay, between e2 prime and e1. So this is e1, okay. Here is e2 prime. So the angle here, okay, from here to here, okay, will be 90 degrees plus theta. It's quite easy. So this is 90 degrees plus theta, okay? Now this is equal C. So this is 1, this is 1. Cosine of 90 degrees plus theta, let's do it this way, okay? Let's from here, I'll write down here, look, this here, okay? This is 90 degrees plus theta, okay? Look, the cosine of this angle here, will be like a sine of theta, okay? That's minus because the cosine here is negative. So this is C, which is minus sine of theta. Now, E2 prime, E2, okay? Now it be CE1 plus DE2 dot E2. So these are going to have D because U1 dot E2 is 0, so this is equal to D. Quite easy, okay? Now the angle between E2 prime and the angle, okay, this is E2 prime, E2, cosine of the angle between E2 prime and E2. This is E2 prime, this is E2. So the cosine of this angle here is cosine of theta, which is equal to D. Now we have A, B, C, and D. Okay? Now let's write down what is the matrix. Don't forget that. A is cosine of theta. Let's write down right here. Okay? Now, then we have E1 prime is equal. What is A? Okay? A is cosine of theta. Cosine of theta, E1 plus. That's C. What is C? Okay? C is here, okay? Is minus sine theta, okay? A plus B, I'm sorry. Okay, B is sine of theta plus sine of theta. E2, you see, this A and B. Now, E2 prime is equal. Now, C, what is C? Minus sine of theta, E1 plus D is cosine of theta, E2. Now we are ready to write the matrix. Okay, I will raise right here, okay, just to write the matrix, which transform, okay, the standard base prime, okay, to the standard base without the prime, okay? Let's put this. So this is E1 prime, this E2 prime is equal. It's quite easy. Now here is E1 and E2, okay? Now, cosine of theta, you see the first row and first column. Here is cosine of theta. This is sine of theta. This is minus sine of theta. And this is cosine of theta. This is my matrix. Okay. Now, you be a good exercise, okay, if you just do the opposite, okay? But I will do for you, okay? I will do for you. I'll raise here, okay? Now, let's write down, okay, or just the opposite, okay? E1 is a linear combination, okay? Let's call P E1 prime plus Q E2 prime, okay? E1. And there's a linear combination between these two unit vectors, so this is the basis. Let's call this standard basis here prime, okay? Prime. Now, E2 is equal, let's call let's call R E1 prime plus S E2 prime. Now, since E1 prime, E2 prime belong to a standard basis, they are perpendicular to each other. See, E1 prime and 2 prime. So, if you write, okay, E1 prime dot E1 prime, this will be 1. This is equal E2 prime dot U2 prime. This will be 1. This is E1 prime dot E2 prime, this will be 0, because it's a standard basis. Now, I will do following the steps that I did before. So I multiply both, I want P, Q, or S. So here, E1 dot E1 prime is equal, here is P E1 prime plus Q E2 prime dot E1 prime, E1 prime. So this is equal, now E1 prime dot E1 prime will be 1, so this is P. Now E2 prime dot E1 prime, you see here, this will be 0, so this will be equal to P. Now let's put here, let's put equal P. Now here we have E1 times the magnitude of E1 prime times cosine. Now the angle between E1 and E1 prime. So this is E1 and E1 prime. So cosine of theta. Okay, this is P. Now to obtain Q, okay, I just multiply both sides by E2 prime. See, this E2 prime, this is E2 prime. Now, E1 prime dot E2 prime, you see, this will be 0. Now, E2 prime dot E2 prime will be 1. So, I have E1, E2 prime, cosine is equal Q. Cosine of what? Between, okay, E1 and E2 prime. This is E1, the E2 prime. You see, the angle here is 90 by theta. So cosine will be minus sine theta, okay? Then I put here minus sine of theta, okay? Because the angle between E1 and E2 prime, you see, E1 and E2 prime is this angle over here. Cosine of 90 plus theta is equal minus, because the cosine is negative, minus sine theta. So this is Q. This is here, this is 1. Likewise, this is 1. Now, to get R and S, I'll do the same, okay? So, I'll multiply here both sides by E1 prime, okay? Now, if I write both sides by E1 prime, this will be R, okay? Now, E2 dot E1 prime is equal, this is equal R, okay? Now I'm jumping the steps that I did, the same thing, okay? Now here E2 times E1 prime, so this is one E1 prime here will be 1. This is E1 prime here, which will be 0, so this is R. Now the angle between E2 and E1 prime. Look, this is E1 prime, this is E2. So this angle here, okay, is 90 minus theta. So cosine of 90 minus theta, this is equal plus sine theta. So R is equal sine theta. Now, this is E2 here, okay, E2 dot E2 prime, okay? Now, if I take the dot product between E2 and E2 prime, here it will be 0 because E1 prime dot E2 prime will be 0, and E2 prime dot E2 prime will be 1. So E2 dot E2 prime will be S. Now, what's the angle between E2 and E2 prime? So this is E2. See, this is E2. This is E2 prime. That's the angle. So this will be cosine of theta. Now, let's write down the matrix, okay? Because we have P, Q, R, and S are right down here, okay? Let's do this, and then, okay, I will have, in this case, E1, E2 is equal, this is E1 prime, E2 prime, okay? I'll get the unit vectors and this and one is standard basis, okay, from the unit vector other with in relation to other standard bases, E1 prime and E2 prime. Okay, let's see, okay, this is P U prime. So P is cosine theta here, and Q is minus. So I have cosine of theta minus sine of theta. Okay, that's P and Q. Okay, P is cosine, Q is minus sine. So this is cosine and this is minus sine. Is the first row. Now let's go to the second row, which is R and S. Okay. Now you see R here. Okay. This will be sine of theta, and that will be cosine of theta. Now it's a very, very interesting. You see, look, this is a second column, this is a second row. Okay, that's the first row. That's the first column, the first row. So this matrix here, okay, one is the inverse. Okay, the inverse. Again, okay, when we work with two different standard bases, okay, the transformation between one base to the other base and vice versa is, instead of you calculate the inverse, you just write the transpose. Okay. Now look, as we did before, if I plug this over here, you see here, if I plug this over here, the product of this matrix with this matrix will be the identity, okay, which will be very, very easy to do it, okay. Or if you want, you can plug this column, okay, and here. So if you multiply, you are going to get the identity, okay, the identity matrix. So V can be written in terms of x1, x2 axis, and the same V can be written in terms of the x1 prime, x2 prime axis, okay, the same V. Now, here is V1, and here is V2. This is V2. The same V, okay, can be written in terms of, you see, this is, here is V1 prime. And also here, in terms of V2 prime. Okay, the same vector V can be written in terms of V1 and V2, and V1 prime and V2 prime. This is written here. Now, I'll do the same as I did before. So, let's suppose I multiply both sides by E1, the dot multiply, okay, the dot product, okay. Then I have here V1 plus V2 E2 dot E1 is equal. Now, on the right hand side is V1 prime E1 prime plus V2 prime E2 prime, okay, dot E1. See, look, I did, okay, the dot product on the left hand side, same on the right hand side. Now, E1 dot E2 dot E1 is 0, and this will be V1 0, V1 prime. Now, I'll write down here E prime 1 dot E1 plus V2 prime E2 prime dot E1. Okay? The same as I did before. Now, if I multiply by, then I see the angles, okay, between this unit vector, which I did last time, okay? I could write here, no problem, okay? What is the angle between E1 prime and E1? Okay, E1 prime and E1. So this will be V1 prime cosine of theta plus. Now, what is the angle between E2 prime and E1? This E2 prime, attention here, E2 prime and E1. So this is 9 degrees theta, because this angle here is theta, this angle here is theta, okay? Now, cosine of 90 degrees plus theta is minus sine theta. So this will be minus V2 prime sine theta. Now, this is V1 in terms of V1 prime and V2 prime. I'll do the same here, okay? Then I multiply both sides, okay? The dot product, I put E2 here, and I put E2 there, okay? This is E2 dot, this is not prime, okay? This is the arrow here, okay? Now, the dot product between E1 dot E2 is 0. So this I have, see, this dot product of E2 dot E2 will be 1. So then I write down V2 is equal. Now, this is V prime 1. This is E1 prime dot E2 plus V2 prime E2 prime dot E2. This is equal. Now, you see, the magnitude of each of these units obviously is 1. So this here you put V1 prime cosine of the angle between E1 prime and E2. This is E2, you see here, is E2. This is E prime. So the angle Okay, cosine of 90 minus theta is sine. Okay, this is sine of theta. Now, the same, okay, plus v2 prime, okay. Now, e2 prime dot e2, so the angle between e2 prime is e prime and e2. You see this angle here? This is theta. So it will be cosine of theta. Now I can write the matrix. Just easy, okay? Look. V1, V2 is equal. This is the matrix, okay? This matrix operates, okay? This is V1 prime, this is V2 prime. This matrix operates in the components of a vector, okay, related to one standard base, to the component of the same vector on the standard base E1 and E2. Now let's write down the matrix. You see, V1 is equal, this is V1 prime, cosine theta, so this will be cosine of theta. Now, minus sine theta over here, minus sine of theta. Now, the second row, okay? Now, V2 is equal, V1 prime sine, okay, this is sine of theta, plus cosine of theta. Now you are ready, without doing any calculation, to write down V1 prime and V2 prime in terms of V1 and V2. Okay? Look, what I will do, okay? You do the transpose of this matrix. It will be quite easy. Okay? I could do a calculation, okay? I write down this here, okay? Instead of multiply by U1 and E2, I would multiply both sides, okay? The dot product, U1 prime, okay? To isolate V1 prime here. And then multiply both sides, okay? Dot product, E2 prime to isolate. If I do that and see, okay, the cosine of this angle, I would get, okay, I will raise here, okay, I will raise the whole thing, okay, I would get, it's good for you to practice, okay. Now, you can write V1 prime, V2 prime is equal, see, this will be V1 and V2. Okay? Now I take the transpose. This is the first row. I put the first column. And this is the second row, will be second column. Okay? Now this matrix, obviously, okay, the product, if I plug this over here, okay, the product of matrix by this matrix will be the identity. Okay, we have seen this case over here, the rotation of a vector, okay? Obviously, okay, the size of this vector, they are equal. I called A, okay? Now, I will give you a hint, okay? Look, when you move counterclockwise from V to V prime, okay, you see here that this component increases, okay? Now, this is x2 component, okay? This case here is different from just the last one we did, because before we rotate the axis, okay? Here we maintain the same x and rotate the vector, okay? Now, you see, you can analyze here and see that when rotate, okay, counterclockwise this vector v to v prime, okay, see the x1 component, okay, decreases. That's why put over here minus sine of theta. Okay, this is sine of theta. Because see, look, v1 prime, it's here, v1 is here. So this sine here, okay, tells us that v1 prime will be less, the length of this vector will be less than the length of this vector. On the other hand, okay, the x2 component, okay, of v prime will increase. That will put here sine theta and cosine of theta. See, that's a trick. Likewise, if you have v1, v2 is equal, now this is v1 prime, v2 prime. You see, look. Now, if you rotate now clockwise, okay, let's put here clockwise, okay, this angle here, okay. Now, you start from v prime, okay, prime here, okay. Now, v1 will be increasing, okay. This is v1. Then he will be plus sine. See, that's a trick. Cosine theta plus sine theta. You just analyze, okay? You compare sizes, okay? Likewise, okay, this is v2 prime. This is v2. So v2 prime decreases. Okay? v prime from v prime to v. Okay, the x2 component will decrease. That's why you have minus sine theta and cosine theta. This is a trick, okay? A hint I'll give to you, okay? But you have to pay attention, okay? You can analyze this exactly the same way as you did with these two x here, okay? The same way. I rotate theta here and theta here. Okay, I have one vector here. Okay, you analyze the component here and the component here. Okay. This is x1 prime, this is x1, this is x2, this is x prime. You can do the same analysis. Okay, just write down the matrix. Okay, that's a trick. Now, let's talk now about cylindrical system. Okay, we're going to use a standard basis. Now, look, suppose the space we have here one circle, then we have three unit vectors. Okay? One which is tangent, we call the theta. The other one is a radial, we call the rho. And the third one, that's called E3. Okay? This is the Cartesian x1, x2, and x3. Now, this curve here projected, the x1, x2 plane will be like that. See, there's a point P here, there's a point Q here. It's the same, we have here, we have a vector, a unit vector E rho, and the tangent vector. Okay, suppose this angle here is theta. Now, because E3 is the same, okay, in this vertical axis here, the same, this is the cylindrical coordinates, so you have here E rho, E theta, and E3. These are unit vectors, okay, representing the cylindrical coordinate basis, okay? And this is E1, E1, E2, and E3 is the same. Now, let's write, okay, E rho in terms of E1, E2, and E3. Okay, then we're going to write E theta in terms of E1, E2, and E3, the same as we did before. So, since they are equal, okay, in the Cartesian coordinate and the cylindrical coordinate, let's work on this plane over here. Okay, that's a plane over here. Okay, there's a circle here. Okay, this is E rho, this is E theta, okay? Now this is E1, and this is E2, okay? Now this is my angle theta, okay? Now, let's use a common origin here, okay? Now, I'll plug here, this will be E1, and this is E2. Now, this is E rho, and perpendicular to E rho, let's put U2 over here, okay? You have E theta. You see, look, what is interesting, okay? This figure here is exactly the same. The procedure we're going to do here is exactly the same as we did before. So we call this E1 prime. And then I called it here E2 prime. Go back there and substitute E1 prime by E rho and E2 prime by E theta. And then you're going to write down the matrix now, okay, which relates, for instance, here the vector here is equal. I can write down E rho here, E theta here, and here I put E3, okay? It's the same. This is the matrix, and this is the unit vector in the standard base, the Cartesian standard base, E1, E2, and E3. You see, since they are the same, the third row here will be 0, 0, and 1. You see, because if I multiply this row by this column, I have 0 times E1, 0 times E2, and 1 times E3. And the other components, the first row, the second row, we just wrote before, okay? When we obtained E prime 1 and E prime 2, just put over here, okay? So, here's cosine of theta, sine of theta. Okay? Now you can write down like this. Okay, I know what to do. Okay? Because let's work on the three-dimensional. Okay? The same thing. Okay? Look. Let's put it right here. So it'll be 0 here and 1 here. So this will be 0. Okay? Now, here is E1, E2, and E3. Okay? Now, That's a 3 by 3. Now, the second row, this is sine, okay? This is minus sine of theta. This is cosine of theta. And this is 0. Okay? That's a matrix 3 by 3. Okay? Now, what this matrix does, okay, the matrix operates in the unit vectors of the Cartesian coordinates, okay, and transform in the unit vector in the cylindrical coordinate. If I want the opposite, okay, just to write down here, let's put E1, E2, E3, that's a matrix here. This is E rho, E theta, and let's write it here, E theta, and in this case, let's put E3. Okay? Now, you just get the transpose of this matrix. This will be cosine of theta. This is sine, you see, sine of theta. And this is 0. I put 0 here. Okay? Now, the second row, this will be minus sine of theta, cosine of theta, and 0. And this, okay, will be 0, 0, 1. Okay? You see, the third row will be the first column, the third column, 0, 0, and 1. So, this is a matrix, okay, that transform the basis, the cylindrical basis, the unit vectors in the cylindrical base to the unit vector in the Cartesian base. Okay, this topic is very important when we study fluid mechanics, strength of material, okay, and in math, okay, that's important. Okay, the reason I'm doing this is because we did for E1 prime and E2 prime, okay, the same matrix. Okay, because here we're working in the three-dimensional space in which the x3 in the cylindrical coordinate is the same as x3 in the Cartesian coordinate. Just it, only this. Let's study what you call reaction cosine. Okay. The reaction cosine is defined. Here we have the Cartesian coordinates x1, x2, and x3. This we have a vector, let's call vector v. Okay. This vector v, okay, makes 3 angles with the coordinates. The first one, let's call this angle here as alpha, okay. This angle here, beta, okay, and this angle here, gamma. Okay, this is gamma. Okay, this is gamma. Okay. So, let's play with this figure over here. First of all, vector v is equal v1 e1 plus v2 e2 plus v3 e3. Okay, look, e1, this is e1, this is e2, and this is e3. Okay. Now, if you project this vector, okay, on the x1, let's put here, And in the x1, x2 plane, you just take a parallel over there. Okay, let's take parallel over right here. Parallel. Okay. Now from here, it will be a parallel to x1. So here is v1, e1. Okay. Here is v2, e2. Okay, if you add v1, u1 plus v2, e2, you just get this vector here. Okay, this vector is v1, u1 plus v2, e2. Now, if you add this vector here on this x1, x2 plane, okay, now this, let's take a parallel to that. Okay, this is v3, e3. Now, if you add this vector here, okay, then my v will be the vector on the x1, x2 plane plus the vector v3, e3. Now, let's get the unit vector in this direction. Okay, let's call this unit vector here EV. EV is a unit vector on this straight line, okay, in which vector V lies. Okay, that's a straight line. Now, how can I write EV? EV, a unit vector, is equal the vector V divided by its magnitude. Okay? Now my vector V is equal vector V divided by its magnitude. If I substitute, okay, vector V, I'll have V1 over V U1 plus V2 over V E2 plus V3 over V E3. Just easy, okay? Because I have a common denominator, okay? And this substitute V over here. Okay? Substitute V over here. And divide each term by this. Now, you see, I would like you to think with me. What is the value of EV dot E1? Okay? Don't look at that, just here. Okay? So this is the magnitude of EV times the magnitude of E1 times the cosine between EV and E1. Look at here, look. Okay, EV and E1 is here, they are here. So alpha is the angle between EV and E1. So this will be cosine of alpha. So EV dot E1 is cosine of alpha. In the same way, the same procedure, okay, EV dot E2, okay, this will be the magnitude of EV times the magnitude of E2, the cosine of the angle between EV and E2. Now, this is EV, okay, and here is E2, E2 here is cosine of beta, which is cosine of beta. On the same way, I'm right here, okay? EV dot E3 will be the magnitude of EV times the magnitude of E3 times the cosine between the angle between EV and E3. This is EV, this is E3, this is the angle gamma. So cosine of gamma. From here, I do EV dot E1. Let's see. EV dot E1. So this E2 dot E1 will be 0, E3 dot E1 will be 0. So EV dot E1 will be V1 over V. Okay? But EV dot E1 is cosine of alpha. So this is cosine of alpha. Likewise, EV dot E2. EV dot E2 will be equal, E1 dot E2 is 0, E2 dot E2 is 1, and E2 dot E3 is 0. This is equal V2 over V. Okay, E2 over V, or EV dot E2, is cosine of beta. And the third one is EV dot E3. EV dot E3, E1 dot E3 is 0, E2 dot E3 is 0, so it will be V3 over V. Okay, E3, in this case, EV, that will be, let's put here the third one I wrote there. Okay, this is the cosine of gamma. Now I can substitute here by, okay, V1 over V will be cosine of alpha E1 plus cosine of beta E2 plus cosine of gamma E3. Now, EV dot V, okay, let's get this dot product here, okay, EV dot V. Now, EV dot V, EV dot EV, this is equal 1. Why? Because the magnitude of EV is 1, magnitude of EV is 1, 1 times 1 is 1. The angle between EV and EV itself is 0. So then I can write EV dot EV, this will be cosine square of alpha, cosine square of beta, cosine square of gamma. See, there's a very important relationship that we call direction cosine. Consider the projection of a plane area S upon a plane pi. There's a plane pi here. Okay? There's a plane pi. If S prime denotes the project area and normal n, see, normal n, and n prime, unit vectors, they indicate the direction of normals to S and S prime. So n prime is a unit vector, indicate the direction of this S prime area. Likewise, the normal vector n indicates the direction of this area S. Okay? Then S prime can be expressed in this, by this relation here. S prime is n dot n prime times S. That's the magnitude. You see, this sign here indicates magnitude because dot product can be negative, 0, or positive, and the project area S prime and S, they are always a positive number. Okay, I will give a very simple example just to explain why we need a dot product between this normal to the S, the area S, and the area S prime. Okay, let's suppose we have the x1 axis and x2 axis, and we have a segment here, AB. Then I have a triangle here. Okay. Now I have BM. Let's call here A, B, and C. Okay. This is my angle alpha. Now we can write that C is equal A. A is the hypotenuse, okay? A cosine of alpha, and B is A sine of alpha. Now, suppose, okay, this is my unit vector. Okay, I will call, okay, I use a standard base, okay? This is my normal E1. You see, this is my E1 over here. Okay? This is normal. This is normal to this length here, BM. Okay? And also, I write down my E2. So this is my, I'll write down here. This is my E2. E2. Here's my E2. You see? Look, E2 is normal to this length AM. E1 is normal to this length BM, which is the segment BM. Okay? Is the length B, okay? E1 is normal to B, okay? The segment BM. And E2 is normal to the segment AM. Now, let's write down here my normal to AB. Okay, normal to AB. Now, let's take the dot product between A1 and N. The dot product and N dot E1. So this will be N, the magnitude of E1 times cosine. Now, cosine between this angle, E1 and N. You can see here. Okay, look, let's do like this. Okay, this is E1. This is N. Okay. Now this E1 and N. Okay. Now, if this is alpha, this will be 90 degrees plus alpha. So cosine of 90 degrees plus alpha. So this is equal to sine of alpha. Okay? See, it's minus, okay? But minus sine, because cosine, okay, when you have alpha, the angle greater than 90 degrees, the cosine is negative, so it's minus sine alpha. Now, N dot E2 is equal N E2, which is 1, cosine. Now, the angle between N and E2, you see, N and E2, you see, this is E2 right here. This is alpha. So this will be cosine of alpha. Now, I will multiply here, okay, by A. Okay, let's call this length here AB. Okay, AB. I called AB as A. Okay, this ABC. C is this segment here. Now this A. Now I can write down, okay, that AN dot E1 is equal, this is minus A sine alpha. Okay, this is minus A sine alpha. Look, what is okay, A sine alpha? Let's think about the magnitude only. Okay, I'll take the magnitude A and E1 The magnitude is equal A sine alpha. What is A sine alpha? You see, A sine alpha is just B. Okay? So what is B? B is the projected segment in this x2 direction. That's why you have A sine alpha. Now, I multiply here by A, okay? So A n dot E2 is equal A, okay, this is 1, this is 1, the magnitude. So what is the angle between n and E2? The angle between n and E2 is cosine of alpha. Cosine of alpha. Okay? Cosine of alpha. Now I take the also, okay? This is A cosine of alpha. So what is A cosine alpha? Is C. So if I multiply the normal to the segment, okay? Multiply the scalar multiplication, okay? A dot. If I take the dot product between n and E2, okay, I will get the projection of AB in this direction, okay? That's exactly what's here, okay? Okay, substitute S by the segment AB and substitute S prime with the segment C. Well, if I multiply the normal to S prime, what is the normal to this segment here? It's E2, okay? If I multiply the normal to this segment, the dot product, to the normal of this segment, to the normal of this area, I get the projected, you see? Now, on this projection, see, this is a projection of AB is small b, okay? Now, if I multiply, if I apply the dot product between the normal to Bn, the dot product with n, I'll get B. That's exactly what I did here. So this is A sine alpha is B. A cosine alpha is C. Now you understand clearly why the projected area S prime is equal the dot product between these two normals, okay, n prime and n times S over here, okay. S here correspond to this segment AB or A. It's clear now, okay? This is a very, very important result to use in strength of material, fluid mechanics, okay, and dynamics, okay? It's very, very important.